So let's look at software development lifecycle in this video. So what is a software development lifecycle? It goes from basically these are some of the images which you can find on the internet. So this will explain different what do you say views of software development lifecycle. So here you have like planning, requirements gathering, design, coding, testing, development, deployment, and maintenance. So this is the typical software development cycle. Depending on your company, depending on your whatever you are using, it could be different, but basic idea is just the same. Like you'll plan and you'll code, you'll test, develop, and then it'll be maintenance. So let's look at some other pictures just to give you a better view. So here it's more of simple planning, defining, designing, building, testing, and deployment. So these are simple steps which you follow for any software development lifecycle. So this is a waterfall model. So where you do one step at a time and it goes only after the other steps is completed. So that's a typical waterfall model which is widely used in the industry before. Nowadays it's more of like iterative and agile script. So here's another nice picture where you see planning, define requirements, design, development, testing. And here's also a linear way of representation where you see the same thing, that is planning, design, write code, testing, deployment. And here is an iterative way of doing things. So you have an initial planning and it goes over cycle, and there's a deployment, and this goes again and again and again. So this is a sort of iterative or incremental way of development. Here you see agile sprints, that is you go in cycles and you have like 3 or 4 week sprints. If you're aware of agile development methodologies, that's how you do things with agile. And now let's look at agile, how it looks like in the, I like pictures because pictures, it's easy to convey a lot of things in just one picture rather than putting in a lot of text. So you have sprint 1 to 4 weeks depending on the company, and you have many sprints, sprint 1, sprint 2, and sprint 3, and each sprint you'll have a running software or a deliverable which will be useful for the customer or the client. And that's what is agile scrum methodology. You have a product owner, product backlog, and you have a sprint, and you have a sprint retrospective where you discuss about what went good and what went wrong in any development environment. So this is just different ways of explaining the same concept of iterative development. You have user stories, product backlog, planning meetings, and you have stand-ups. These are all agile terminologies which is commonly used for any project. So let's look at waterfall. Waterfall has been traditionally used in previous, like it's still used in avionics and many of the automotive projects where requirements are very clear. So you have concrete requirements, then you go for waterfall model. It is bit of rigid because one step starts only after another step finishes, and it's a bit costly also because once you finish some development and you want to change, you have to change a lot of things. So this is some of the different models in waterfall and development cycle. There are even more models, like here you see, if you go you can see even more model like waterfall, iterative, spiral, prototype model, design model. And iterative model, as I said, is like it just goes in different iterations, and each iteration will have a sort of a deliverable or a working product which can be used. So this way the requirements can be refined and the software will become even more better. Spiral model, as the picture shows, it starts off in the center and then iterates over time. So you have the requirements gathering, then goes the other steps like testing and development. So let's look at some other maybe a bit clearer picture. This one is a bit clearer where you see the steps going clearly, like risk management, prototype, design, code, integration, test, and implementation. And also there's two axes like cumulative and review and release. That's a bit of complex. I'll explain a bit more in detail in some other section. So for now, you have looked at different development models of software development lifecycle. Basically, it's the same. That is, you initially gather requirements, you make the design, then you make the development, and then testing, and then maintenance. That's the basic core principle. But mostly we use different methodologies for implementing this this sort of work. So let's look at DevOps, what it means in a very brief way. So it's a widely used terminology now, and it's also a very important skill set. So it's basically a sort of a method where you do development in an iterative way, and also it's a sort of a principle where things run automatically. So you see some pictures here where you have the source code, version control systems, and how things run in this pattern. Yeah, and since we use continuous integration for the development, so once you write a code, it gets compiled automatically and it goes to an integration system, and if there's a bug or something, the system crashes, and then you will get some bug report. So this is a completely automated system where once you start coding, it goes into the version management. It's automatically taken by the continuous integration and continuous development system. The code is compiled and it's taken to the next level. And if the build fails, then it will be logged, and the people or the developers have to fix that, and then it basically improves. So it's basically connects people, process, and technology together. And here is like a DevOps tutorial from Microsoft which you can go through. So it just says what is DevOps. That is, it's a software development practice which promotes collaboration between development and operation. That is the main thing. It promotes collaboration between development and operation, and there was a gap between this. So this concept has picked up very well, and is referred to as a culture rather than a process or a technology. It's a highly development process has been highly manual, so this has enabled to make it bit more automatic, and it is to it has created efficiency across all tasks and connecting the development operation. That's the key. So DevOps is all about connecting the development and operations and increasing the visibility. So what makes DevOps different from other devices is like other practices is it bridges the gap between development and operations, creating a significant efficiencies across development, deployment, and software. And the philosophy of DevOps is to take end-to-end responsibility across all aspects of the project, unlike more traditional methods that is developing of software. So that's the responsibility is taken for all the aspects. So anything you just make one step wrong, it's going to not work. So it's just very irresponsible thing. And agile is just complementary. So these are a bit of targeting two different purposes. So agile is lean manufacturing process which that helps provide software development production framework, and is often specific. Agile is often specific to development team where the scope, and DevOps is more of a general thing. Yeah. So these are some of the things, and agile planning and lean project management means agile development is a delivery approach that relates to lean manufacturing, and development is completed in short incremental sprints. We just saw in the last video, and the DevOps has two approaches, mutually exclusive. So these are two different approaches. Version control is where you document the code and it takes different versions. It's a crucial part of the software development process. A version control system such as Git or GitHub takes a snapshot of your files and letting you permanently go back to different versions of the software. Continuous integration is a process where you build the code continuously as the developers are developing. So it's like an assembly line in a car manufacturing industry. That's the whole idea. So you continuously code and it's already continuously integrated into the system. So you have that's why we call continuous integration, and we need to have a very good quality code in such a system so that you any bugs are identified quickly and identified and removed. Continuous delivery is a fundamental practice that occurs with DevOps, enabling the delivery of fast, reliable software. While the process is similar to the concept of DevOps, but continuous delivery, but here the code is tested, validated, and committed. And infrastructure as a code, whether on premise or on cloud, provisioning and configuration of resources is a key part of environment operations, and through process automation and use of tools provide a declarative definition of infrastructure. So this is another important aspect of DevOps. Then you have monitoring and logging and validated learning, which are another two important aspects which you need to know in DevOps. So monitoring logging scope of DevOps goes beyond development, maintaining responsibility of the software through delivery. So including software performance, entire process of DevOps creates a feedback loop and ultimately providing data points that can help improve the future projects and validates the decision of deployment. So that's about monitoring and logging. Validated learning throughout the life cycle, feedback and telemetry data are gathered to help inform decisions from next cycle. This information referred to as validated learning that provides insight into new ways to reduce the amount of time per cycle, and the gathered data is then used a way to increase automation. That is, you gather data and experience which is fed back to the system. So this is the rough concept of DevOps. You can go to this Microsoft site to have a reading or understanding, and you can also Google around. You can put in Google. There are a lot of information out there to learn about DevOps, which is a quite very important development methodology nowadays. Many companies are asking for it, this skill set, so it's worthwhile to learn about it. So hope this has helped you. So do ask any questions if you have. I'll be more than happy to help you. Thank you.